Hi everyone. In the previous video, we have seen how the centroid divides the medians, and here in this video, we are going to see how to calculate the length of the medians. So let's get started. Here I have a triangle in the diagram, triangle ABC, where the side AB is denoted by lowercase c units, and the side length BC is denoted by lowercase a units, and the side length AC is denoted by lowercase b units. And also we have the angle BAC, which is the angle near the vertex A. That angle is denoted by an uppercase a degree or a radian, really doesn't matter. Let's just denote that with uppercase A. And similarly, angle ABC, which is the angle near the vertex B, that angle is being denoted by uppercase B, and then angle ACB is being denoted by uppercase C. Now for this triangle, we are going to draw one median, and then we are going to see how to calculate the length. So let's first draw the median. Let's suppose we have a median AD, which is joining the vertex A to the midpoint D of BC side, and BD will be equal to DC, and each of them will be half of A, because BC is denoted by lowercase a. So if BD is equal to DC, meaning if D is the midpoint of BC, then obviously BD will be equal to DC, and each of them will be equal to half of A. Next, we are going to use the cosine law on the original triangle, the triangle ABC. So using the cosine law on the original triangle, what do we get? Well, we get cosine of B is equal to c squared plus a squared minus b squared over 2 times ca. I have already posted a video on the cosine law. Feel free to watch that video. I will share the link in the description. So using the cosine law on the original triangle, we get that cosine of B is equal to c squared plus a squared minus b squared over 2ca. And similarly, we are going to use the cosine law on the smaller triangle, which is triangle ABD. And using the cosine law on the smaller triangle, again we calculate cosine of B, that will be equal to AB squared plus BD squared minus AD squared over 2 times AB times BD. Now if you look at both of these equations, you see that the left hand side is same, it's the cosine of B. That means the right hand sides better be equal. So equating the right hand side of these two equations, then we get AB squared plus BD squared minus AD squared over 2 times AB times BD is equal to c squared plus a squared minus b squared over 2 times c times a. Now if you think about AB is nothing but lowercase c, so we can say this is c squared plus BD squared. What is BD? Well, BD is actually half of A. And then what is AD? Well, AD is the unknown that we are going to calculate, so I am going to keep AD as is over 2 times AB, so it would be 2 times AB is actually lowercase c units, and then BD is actually half of A, and all of this is equal to c squared plus a squared minus b squared over 2ca. And now you see a couple of cancellations could happen. So this 2 and this 2, they will cancel out each other, and then this c and this c, they will cancel out each other. Similarly, this a and this a, they will also cancel out each other. So now on the left hand side, the denominator is just 1, and on the right hand side, the denominator is just 2. And now what we are going to do, we are going to multiply both sides by 4. So if we multiply both sides by 4, then what happens? It would be 4 times c squared plus a squared over 4 minus AD squared is equal to 4 times c squared plus a squared minus b squared over 2. And from here you can clearly see that this would be 4 times c squared plus a squared minus 4 times AD squared is equal to 2 times c squared and then 2 times a squared and then minus 2 times b squared. And then let's keep 4 times AD squared on one side, and then let's keep everything else on the other side. So from here, can we write it like this? We can say 4 times c squared plus a squared minus 2 times c squared. I am bringing everything to the left hand side, and then minus 2 times a squared and then plus 2 times b squared. And then let's bring the AD squared onto the right hand side, so that would be positive 4 times AD squared. And from here we can clearly say that 4 times AD squared would be equal to, let's simplify this a little bit. So we have 2 times b squared, and then also we'll have positive 2 times c squared, and then we're going to have a negative a squared, and that's about it. So from here we can then say then AD squared would be 1/4 of this quantity, 2 times b squared plus 2 times c squared minus a squared. And from here we can say, well, then AD will be equal to, if we take a square root on both sides, then it would be half of square root of this quantity 2 times b squared plus 2 times c squared minus a squared. That's one important result. And also we are going to try another thing here. Now I'm going to write it over here. So we got AD equals half times 2b squared plus 2c squared minus a squared, and I'm going to keep the half as is, and then within the square root, can we write it like this? Can we say that let's keep 1b squared as is and 1c squared as is, and then we can also write another b squared like this. So because we originally had 2b squared, so I am writing it like this, and also we had 2c squared, so we can write it like that, and then we had a negative a squared. And now from here, if you carefully look at this quantity right here, b squared plus c squared minus a squared, we can actually convert that into cosine of a angle. Why? Because from the cosine law we know that cosine of a would be equal to b squared plus c squared minus a squared over 2 times bc, and from here if you think about it, we can say, well, then 2 times bc times cosine of a is equal to b squared plus c squared minus a squared, and I'm going to use this value right there. So I'm going to use this value in place of b squared plus c squared minus a squared. So if we use that value, then what it is going to look like? Well, then it is going to look like half of square root of b squared plus c squared and then plus 2 times bc cosine of a. So that is another value of AD. So let me just write it down here. So this is actually AD. So I can write AD equals half of square root of b squared plus c squared plus 2 times bc cosine of a, and that is another important result. Let me highlight that, and I'm going to erase the bottom portion in yellow right here. So let me erase that part. So now we can see that there are two different ways that we can calculate the length of a median. Now AD being a median, we have been able to express the length of AD in terms of the side lengths, which was the first derivation we did, and then in the second derivation also we can express the length of AD in terms of the length of B and C and A angle. And similarly, if we draw the other medians, we will be able to calculate the length of the other medians. Let me draw the medians first. So I have drawn the second median, which is BE, and the third median, which is CF, and if we deploy the same technique, we are going to find their length also. Let me just make a summary note here. I'm not going to go into the derivation of the two other lengths. I'm just simply going to write down the formula here. You can try the same technique and you will be able to come to the same formula. Now length of BE will be like this. Length of BE will be half of square root of 2c squared plus 2a squared minus b squared. And if we write it the other way using cosine of the angle, then we can say BE will be equal to, so I am writing it over here, half times square root of c squared plus a squared plus 2ca cosine of b. And what would be the length of CF, the third median? Well, CF's length will be like this, half times square root of 2a squared plus 2b squared minus c squared. And if we denote it using the cosine of the C angle, then we can say CF will be equal to half times square root of a squared plus b squared plus 2ab times cosine of c. So this is how we can find the length of each of the medians. If you are given the side lengths of a triangle, then we can use the formula which are on the right hand side, because those formula simply uses the side length. And if you are given two sides and the enclosed angle from the original triangle, like if you are given the side length b and c and the angle a, or if you are given the side length c and a and the angle b, or if you are given the side length a and b and the angle C, then you can use the left hand side formula to find the length of each of the medians. I hope everything made sense. Thank you for watching. See you in the next video.